Okay, so DMA 50 sections 1, 2, and 3, we're going to be starting working with graphs. Sections 1 and 2, we are going to read and interpret graphs. And we're going to start by talking about different kinds of graphs. Some of the different types of graphs that there are what we call pictographs. Pictographs use images or pictures for those particular types of graphing. If it were Valentine's Day, it may be in the legend you may have that a heart would equal, say, 10 Valentines. And if somebody had a heart and then a half, that would be equal to, you could use the legend and determine that they would have had 15 Valentines given to them. So pictographs use images to represent information. If you have a bar graph is going to be one of two. Either it's going to be a vertical bar graph or it's going to be a horizontal bar graph. So if we had a vertical bar graph, it would be represented with bars of information. So each of the bars here would represent. If it were a horizontal bar graph, the only difference is that the bars are read horizontally versus being read vertically. Now, since I just mentioned a bar graph, let me share with you a special kind of bar graph called a histogram. With a histogram, that represents a range of data. So for a histogram, let's say what we would do first is you would tally data. So it could be you might have data for people when they're from ages 10 to 19, 20 to 29, 30 to 39, 40 to 49. And whatever information you're gathering from these, as you're collecting the information, you would use, say, tick marks to represent how many you may have of each. And if you're doing data for a histogram, it's going to look like a bar graph. Let's see. We have one here, one that would be higher, one that would be a smidge higher, and one that would be less. So with this, the first bar would be all of the people from ages 10 to 19. The second one would be everybody 20 to 29. This one would be the 30 to 39. And the last would be the 40 to 49. So with this type of graph, the first one has a total of 6. This one is represented by 10. That one would be 7, and the last one would be at 3. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So with a histogram, it's a bar graph, but each bar represents a range of data. And usually when people collect data, they use tallying to keep up with the data, because it would be really outrageous to do like age 10, 11, 12, 13, 14. I mean, you have to have a set of 10 for each of these, whereas you can have a whole decade age range in one. Another type of graph that we look at is what's called line graphs. I'm sure you're familiar with a line graph. With line graphs, usually, and line graphs oftentimes represent data from various different areas. So it could be you may have a line graph to show increase and decrease. And if you're doing a comparison of, say, profit and loss for a company, you might be able to see in different colors, different years. So sometimes you might have a lot of different data that can be represented, and usually they color code and they change in the legend that information. And since I mentioned those words, the key or legend is what you're going to be using to identify the info for the graph, for the table. Every graph that you have generally is going to have a title, and then they're going to use labels on both the X and the Y axis so that you know you would have a label down here for this information, and you would have a label on the side also for that information. In a moment, I'm going to pull up my Labs Plus and show you what some of this is going to look like on the computer, because there's a few things that you need to be aware of, some of the buttons that you'll find that you're going to need to use on those. There's another type of graph, and all of section 2 is on this type of graph, which is the circle, or sometimes you may hear it referred to as the pie graph. When you have a circle or a pie graph, the entire circle represents 100%. Each slice of it may represent a different amount. So let's say if this is representing your budget, it could be, let me break it up into some parts here. Okay, so let's say we have 25% that you spend on food. Let's say you have another 25% that you spend on savings. Let's say you spend 35% on your bills, and you spend 15% on entertainment. So when you're working in the section for the pie graphs, the circle graphs, each of the slices of the pie, each section is going to be represented by a percentage. All four of the percentages, when you add them, has to total 100. If, for example, let's say, hang on. Oh, wait a minute, where did it go? Huh. Hold on just a minute, it just disappeared on me. Let me pause this a second. Okay, so if, for example, if your budget, if the 100% represented $2,000 was the amount of money that you had, and I want to know what amount is spent on food, you would multiply the decimal part, the 25%, times the 2,000 to get how much is spent on food. If the bills was 35%, 35 divided by 100 is a 0.35, multiply that by 2,000. For the entertainment being 15%, you would multiply the 15% times the 2,000, and the savings is going to be the same amount as what you spend on the food. And I was just making these up. So let's do 2,000 times 0.25, that's going to give us 500. If we do the 2,000 times the 0.35, that's going to give us 700. And the 2,000 times the 15% is going to give us 300. So that means we would have here $500. Here would be $700. Here you spend $300, and this one is the $500 a month. So as you're working with problems in this section, you may be needing to calculate those amounts. So let me show you here what that's going to look like. So I just went into section 1 of 50, and I'm going to go and find a graph where I can show you a couple of the items that you need to be aware of. Okay, this is an example of a pictograph. The pictograph shows last year's fruit production by the top fruit producing regions. Which region produced the greatest quantity of fruit? Here in the legend, 25 million bushels is represented by each of the little bushels. And if I look at this, all I have to do is look at the picture and I can see that the coastal region here has the most, and I can see that the lake region has the least. So just by looking at this visually, you can determine which has the least, which has the most. So here we'd say the coastal region has the most of those. So they've got a couple of questions on that. Here's another pictograph using a flame to represent 12,000 fires. Which year had the most wildfires? So just look and see which is furthest out, and that would be the year 2002. More pictographs. Okay, here is a horizontal bar graph that you're using to interpret data. This is a vertical bar graph representing data. And again, you have the months of the year here, and then the number of tornado deaths listed on the left-hand side. I'm just trying to jump ahead. And all of these graphs, you can read the information based on what they have given you. I'm trying to get to one. Here we go. This one says, how many adults drive 150 to 199 miles per week? So if I look here, this is the 150 to 199. But do you see I can't exactly tell what number that is? There are 1, 2, 3 places here. You've got the zoom in, the zoom out in the middle. I like the bottom one called pop out. If you choose that one, it makes it large enough that you can read. So now when I'm reading here, if I had a piece of paper, I could line it up, slide it over, and I could see that my answer here is going to be 4. It's one tick mark beneath the 5. So when you have a graph, if you see these buttons on the side, you're going to want to choose the pop out so that it will make the graph larger, and it puts up all those extra lines so that you can actually be able to read that graph much more legibly. Again, here's another one. Pop it out and you can read the values a lot more easily. And here, if you're trying to look at these, all of these at the bottom have a pop out, so you can also read those more carefully as you're making your choices. Okay, let me go to the second section where we have our circle graphs. Oh, wait a minute, went too many sections out. The screen popped under my pen. Okay, let's try that again. Okay, here's section 2. All of section 2 is going to be on circle or pie graphs, pie charts. So here the entire circle represents 1,000 college students. They were asked where they live while attending college. Use the graph to find where most of these college students lived. Most of them lived, and you could look at which piece appears to be bigger. It's either the blue or the green. The blue is 320, the green is 380. So it would be the campus housing would be where the majority of the students were living. Sometimes you're just reading the information, and then sometimes you may have to do, this one wants you to do a ratio. That relates back, remember, to dma050. Find the circle graph that shows the cost of adding an art studio to an existing building. Find the ratio of the cost of materials to the total remodeling cost. So materials is 9,400. So we would do 9,400 over the total remodeling, they don't tell us that amount, but if you add all of these values together and get a total, that's going to be your denominator. So you'd have 9,400 over the total addition of all of those. And then it says type an integer or simplified fraction. So you'd want to reduce your fraction answer for that question. But again, everything in this section 3 is going to be all relating to reading and interpreting pie graphs or circle graphs. Here, if the library has 124,000 books, the number of books in the reference or other category. So reference is 17, other is 3. If we add 17 and 3, we'd get 20%. So we would calculate 20% of 0.20 times 124,000. And that's where we would get our total from. Okay, so that's what you're looking at in section 2 is all of reading and interpreting your circle graphs. The third section that I'm going to share some information with you on is about the coordinate system. So let's come here and on section 3, let me make that wider. For section 3, what I want you to notice is that we have horizontally, this is called our x-axis. Vertically, this is called our y-axis. Our rectangular coordinate system is divided into 4 parts. We have quadrant number 1, we have quadrant number 2, we have quadrant number 3, and we have quadrant number 4. It would be like the letter C. It would be counterclockwise. When we look at values on this system, as you go to the right, your numbers are going to increase and they are positive. As you go left on the x-axis, your numbers are negative and are smaller as you go to the left. As we go up on the y-axis, our numbers are positive and increasing. As we go down, our numbers are negative and decrease. If we are graphing something in each of these ordered systems, in this first system, our x is positive and our y value is positive. In quadrant 2, our x is negative, but our y value is positive. In quadrant 3, both the x and y are both negative. In quadrant 4, the x is positive and the y is negative. There is a special point here, the very center where the lines intersect, that ordered pair would be 0, 0. That has a special name called the point of origin. When you are graphing your ordered pairs, and this is called an ordered pair, an ordered pair is made up of an x and a y value. I want you to pay close attention to the fact that the x value is going to go either left or right. The y value is going to go either up or down. If the x is positive, it goes to the right. If it's negative, it goes to the left. If the x is a 0, it's going to stay right there on the line in the middle. For the y value, if it is positive, it's going to go up. If it's negative, it's going to go down. And if it happens to be a 0, it's going to stay right there on the line. So when we plot points, we're going to be looking at what is positive and negative as we may need to graph those. So let me do one more. and let's try graphing a couple of ordered pairs. So if this is my axis, and I'm going to graph 1, 2, 3, 4. Okay, so let me give you some ordered pairs. Let's say we want to graph 2, 4. That means I'm going to go right 1, 2 places, and then I'm going to go up 1, 2, 3, 4. So right up here is going to be my ordered pair 2, 4. If I'm going to graph, let's say -3, 1, starting at the point of origin, I go left 1, 2, 3, I go up 1, and that would be this ordered pair. If I'm going to graph, let's say -2, -3, I'm going to go left 1, 2, and then come down 1, 2, 3. And if I'm going to graph, let's say 4, 1, I'm going to go right 1, 2, 3, 4, and then go down 1. So, oh, excuse me, 4 and -1. So that gives me ordered pairs that would be in quadrant 1. This is quadrant 2. This is quadrant 3. And this is quadrant 4. Another thing I haven't named yet that you will graph, we talked about the point of origin here. That was special. That's our 0, 0. We have something called x-intercepts and y-intercept. If I graphed a point here, that point would mean I went right 1, 2, 3 places. I didn't go up or down, so it would stay on the 0. This, since it is on the x-axis, this is called an x-intercept. If I were to graph a point, let's say here, I don't go left or right, so my first value is going to be a 0. I stay on the line. But then I'm going to go down 1, 2, 3, 4. So 0, -4. And since my value is on the y-axis, this is called a y-intercept. We're going to have a whole section 5 that we're going to work with looking at x-intercepts and y-intercepts. So this is just a little bit of the beginning of manipulating and doing that. Let me come back here for just one moment and let me go under the assignments because I want to show you on the computer when you are doing some of these problems, you're going to have to be able to move a point here around to be able to graph. Okay, so for this one, the coordinates of A, well, here they want me to put the ordered pair. That will be a 0, 0. It's at the point of origin. Let me find one where they want me, and this is asking for the ordered pair. For C, I would go right. Let me make it bigger here. So if I'm identifying this, I would go right 1, 2, 3. So it would be 3, and then up 1, 2, 3, 4. So 3, 4 would be the ordered pair, and you always have to put the ordered pair in parentheses. Okay, let me jump out several problems. I want to find one where they're making you graph it so you can see how to manipulate that. Well, maybe I went too far. Okay, for some reason, I'm not finding what I'm looking for, but what I want you to be able to know how to do is that if you are given a graph and you need to graph, there's usually a place in the middle and you touch it, click on it with your mouse, and then slide it to the location that you want to move to. So if you're graphing a point, it's usually going to be a dot at the point of origin, and then you move it to the correct location. And that is it for the first three sections that we have here.